yeah, so essentially I'm going to talk about how I think like a local binding is happening, and I think this is a recent kind of like insight. I'll just walk you through a bunch of slides very quickly, but it's more kind of to get the conceptual picture of like what I'm driving towards. So first is, okay, like we live in a tiny world simulation generated by our nervous system, and it's kind of this like diorama-like shape. It's kind of like we're in a tiny theater generated by our brain. I would claim that this theater is populated by something that resembles kind of like cell animation elements, how cartoons used to be made. You put kind of like these transparent sheets, and you put different objects in different sheets, and then you can control them separately. It seems like, at least based on phenomenology, especially psychedelic phenomenology, that there's kind of these like cell animation elements that populate our visual field, and they can like rotate, they can be translated, recursively stacked on top of each other. More so, phenomenologically, they seem to be kind of like holographic in that there's a little bit of a parallax embedded within them. And on top of that, they interact with each other. So like this is, for example, on DMT, several of the cell animation types maybe kind of like, in some sense, talking to each other and exchanging information. So how is that happening? Okay, so here's the big reveal. I think there might be kind of like a circuit essentially built with nonlinear optics that allows your screen of consciousness to effectively being seen by multiple witnesses and interacted with by multiple witnesses in a collective fashion. And essentially the following is the following optics, I think, matter. One is beam splitters to kind of like double an image. Also birefringence. This is a property of optics where you get kind of like double images because a material has two index of refractions. And TV stones. So this is like a material that essentially just kind of like teleports an image from one side to the other through fiber optics. Okay, so here's the circuit I have in mind. On the left side, you have like the square. I think, like, let's say that's your screen of consciousness. If you put an image on it, through TV stones and beam splitters, it gets like sent to like many other modules. And then our brain is kind of like it's a neural network, but let's say like a nonlinear optical neural network. So the thing that they modulate, the synapses, might be things such as like, hey, how much we feed this image through a birefringence, channel, how much through diffraction, how much through refraction. So each of those provide a different alteration on the image. And then finally, you pull together those alterations, and you feed it back to the original screen. And then off you go again, and you do it recursively. So I'm going to say that the actual moment of experience that you're having is a stable equilibria where the screen is being broadcasted to all of these different kind of sub-agents, is being worked with independently, and then fed back to the screen. And I think like this might explain, Indra's net, everything reflecting everything else, and how, many sub-agents can interact within you normally, but especially on states of consciousness like those induced by DMT. So anyway, that's my presentation, and I'll hand it over to you guys.
And now we're going to have Professor Levin give a quick intro about who he is and what he's working on to the University of Toronto.
Yeah. Hi, everybody. Thanks for having me on. That was super interesting. I look forward to talking about it. I am a professor of biology. I work at Tufts University near Boston, and my group does a lot of our practical things end up being applications in regenerative medicine, so birth defects, traumatic injury, regenerating organs, cancer normalization, aging, things like that, synthetic bioengineering, and so on. But all of these are driven fundamentally by our attempt to understand how minds exist in the physical world. So trying to understand what does it mean to be a cognitive agent, and in particular in very unconventional embodiments. So in our work, we really loosen a lot of categories and things that have been kind of frozen in philosophy of mind for many years in terms of what it means to have an embodiment in weird spaces that are not three-dimensional space. What does it mean to be an agent at really unconventional scales of both time and space, and many questions like that. And what we do is basically drive ideas on these ancient philosophical questions about what is a self, how do collective intelligences assemble and then split and transform, given that we are all sort of originate as single cells and then eventually become whatever it is that we are now. And so these kind of dynamics, these kind of the appearance, the scaling, and the intelligence of very unconventional kinds of minds in the physical world. And so we are interested in ways to recognize them, ways to communicate with them, and really to have ethical interactions with minds that are not at all like ours. And those kinds of things have very practical applications when we learn to communicate with a collective intelligence of cells navigating anatomical space. We discover things that look like solutions to birth defects, to regenerative medicine, and so on. But fundamentally, what these are frameworks to communicate with agents that we've, whose intelligence we just haven't recognized up until now. So that's our research program.
I think me and Professor Barenholtz are going to jump in here because I think Andres has some very interesting thoughts, as do you. And I know a lot of people have wanted to see both of you guys talk to each other about things like the binding problem. So Andres, if you have a particular question that you would directly address to Michael right now is your chance.
Yeah, I mean, I guess the the very big picture is if you've thought of like maybe the role of like optics and like nonlinear optics for like how agents or sub-agents may coordinate with each other, or maybe kind of like levels of of holograms controlling holograms, as it were. If this is something you've thought of.
Yeah, well, a few things. First of all, have you ever seen that there's a really interesting book called Shuffle Brain? Have you ever come across that by this guy?
Oh yeah, I just got it. I haven't read it yet, but I just got it, and yeah.
Take a look because half the book is kind of experiments on moving pieces of brain between animals, which and then some very interesting experiments on the nature of memory. But half of the book is a kind of holographic theory of learning and recall. And I think you might get a kick out of it based on your interests. I mean, for us, in terms of this binding problem, we've been studying several different kinds of what I call cognitive glue, which are mechanisms and policies that allow competent subunits to come together and become some kind of a whole that's more than the sum of its parts. It knows things that its parts don't know. It has goals, it has preferences, and it navigates spaces that its parts don't know how to do, right? So we've been studying in particular two kinds of cognitive glue. One is this thing related to memory anonymization, which is the way that electrical networks enable cells and tissues to join into larger systems that in part make it very difficult to know whom any given memory belongs to. And once that happens, you get this interesting mind meld that allows a collective to have ideas that the individual pieces don't have. And then the other type of cognitive glue is stress sharing, which is an interesting kind of stress being the driver of homeostatic loops. So it keeps subunits operating towards some kind of goal. Well, it turns out if your stress is leaky and you just share it to your neighbors, they are under incentive to help you achieve your goal without altruism. They're not trying to help you. They just want you not to stop stressing them out, basically. And so those kind of dynamics end up aligning components towards goals that are not really their goals. They're kind of higher level system goals. So those are the two things we've studied. So we have not directly studied anything optical in that sense. However, there is a really interesting field of biophoton research. And there have been people for many decades, going back to the 1920s with Alexander Gurevich, who have basically said that the biophotons that cells and tissues emit, and there are many different kinds that they put out, are really fundamentally a coherent field that in some way binds them towards large-scale cooperativity and a scale-up of intelligence. Now, my gut feeling is that probably is real, but I don't have any data about it. And the state of the field now is that people are pretty good at reading those kinds of signals. I mean, we have fancy photon multipliers and things where you can actually see these ultra weak photons, mostly in the UV range, being emitted from cells under various conditions. So we know they're there. But we have not gotten to the point, as we did with bioelectricity, where you can actually now write messages into the medium. So we don't know what the signals mean. We don't have that functional data set to be able to say, okay, I wrote a new message and I got you to do something you weren't going to do otherwise. So now I know how you interpret that message and so on. So that's as close as I can get to the optics stuff. It's not our work, but I do think it's promising. And The future advances in the technology here, I think, are needed to be able to say something more concrete about it.
Amazing, amazing.
Can I jump in real quick?
Yeah, go
Mhm.
for it.
Hey, it's Elan Barenholtz. Andre, good to see both of you again.
Good to see you.
We talked about this, and I'm going to jump in with a very similar question to what I asked you earlier, and I think this is a perfect opportunity to do so, because you are, I think, in some ways, a little bit talking somewhat orthogonally to each other, because I think what Dr. Levin is talking about is kind of functional binding, where we're seeing some sort of actual output of a system such that it requires some coordination amongst different systems. And I think what you're talking about, here's what I'm going to pose to you, is it's kind of phenomenological binding. And, this is a question I think, this is something I've been thinking about deeply, actually, since your presentation that I saw just a few weeks ago, is to what extent we can actually say there is true that phenomenological binding is real. That what we measure when we talk about binding, so the kinds of things like the serial search, for example, which requires binding of multiple features, right? You have to look for the red slanted line, and that requires a lot more time, serial time actually, based on the number of targets, and as opposed to say pop out. And so it appears that that this ability to combine things in our mind is subject to what we call attention. Now, one way to think about that is that the process of producing this specific output, namely I identified a target, is what is requiring this binding. That what that suggests is that maybe we have to think more operationally in terms of functional, in terms of the kind of binding that Michael's talking about, that when you have to produce a certain output, namely this object has two properties, that's when you need to bind. But generally speaking, maybe we aren't binding, in the sense that maybe the quality of the qualitative binding that we all think we have of a unified subjective experience, where objects have multiple properties, where the modalities are combined into a single subjective experience of self, may in fact, I'd even go so far as to say, be illusory, and only is just in time, namely when you have to combine these things under these specific behavioral constraints. And in fact, it's not my show, I'm not going to jump into this right now, but my autoregressive theory that I'm pursuing actually sees the binding as being part of the autoregressive process, this serial sequential process that is slow because you have to do this kind of combination of multiple features. And I guess my question is there really a unity of consciousness? And if that's what you're after, is there a way for us to probe it outside of these kind of operational definitions, which are functional rather than being subjective?
Yeah, I mean, if I can share my opinionated perspective, is there a unity to consciousness? The answer is yes, and I think it is functionally significant, and it is distinguishable from other functional types of unity. A couple like specific comments on what you commented on. One is I think phenomenal binding is happening whether we are like put to a task or not. I mean, there's a lot of kind of like unsupervised, kind of like phenomenal binding that is happening all the time, prepping up for the possibility of maybe being applied for something. But I think a lot of it just also happens like spontaneously without any particular goal in mind. And there's also kind of like many levels of attention. Attention, broadly speaking, does help, especially with local binding, like putting features together. When you pay attention to two things in sequence, the features of those two things do somewhat become combined into kind of like a hyper object, as it were. But there's many levels to attention, and I think like a classic example is like Ramachandran's work on synesthesia, where like you could do a visual search process, in an accelerated way, by essentially, if you have a certain type of synesthesia from, let's say, like shape to color, right? Like there's like a lot of S's and just a couple fives. Somebody with synesthesia, the fives may just like pop out, So this is a case where you have kind of this like massively parallel, aspect of phenomenal binding that is happening in a sort of like pre-attentional way, or like maybe the attention is still kind of very distributed. And then it's accelerating this like search process. To me, suggesting that, yes, there's many levels of phenomenal binding that is happening. The phenomenal objects are being put together and many levels of the hierarchy. And eventually, yes, they do come together kind of like all at once for coordinated behavior, but there's a lot more that is happening besides that. In particular, like, why is there like this phenomenal binding in addition to functional binding at a larger scale? I mean, I think like that will require us to understand like the role, you know, that the unity of consciousness is playing. And my main take here is that the unity of consciousness evolved because it functions as a kind of hardware accelerator. I mean, effectively, the fact that experiences are kind of like happening all at once is a method by which the organism coordinates. It sort of like pretends to be this lower dimensional surface, and then it has this coordinate system along which it can kind of like, you know, find and send signals to each other. Maybe you can think of it as a form of like massive dimensionality reduction. I tend to think of it almost as also as a way of interfacing fields of different dimensionalities, like the act of compressing, you know, a three-dimensional tactile field and making it synesthetic with a two-dimensional visual field. That can benefit from, for example, yeah, like, you know, holographic physics. And to the extent that it benefits from that, evolution would have a reason to recruit to those physical processes. And so, yeah, it may be phenomenal binding is actually, yeah, this, you know, actual physical thing that is happening, which is relating fields of different dimensionalities. And I guess I want to mention, yeah, like one there's of course, yeah, like a lot more to comment on, but I want to, yeah, cede my word in a second. I want to mention that, like, yeah, the two mechanisms for like cognitive glue that yeah, Michael, you propose, yeah, they sound fascinating, and I think they definitely they seem right. And I guess I've thought in similar terms. So you mentioned like stress sharing. I think perhaps like maybe like a broader concept would be kind of like valence sharing, essentially like sharing, yeah, like your pleasure pain axis across organisms, where stress and the risk of strain is one of the components of valence, but others being things such as like multi-scale harmony, for example, as like a target to drive towards, where like, hey, like if each of the components of a system is trying to maximize its own harmony, but then its harmony is actually entangled with the harmony of the system to which it belongs, then yeah, it's going to try to improve the valence of the organism as a side effect. And also, yeah, like memory anonymization sounds super on point, like, and it has to do with kind of like the blending of identity that I think like seems to be necessary. One third cognitive glue, I may add, based on psychedelic phenomenology, would be sharing symmetry groups. So for example, on DMT hallucinations, I mean, I think that this happens all the time, but it's like much more obvious in some of these states of consciousness. There might be like a region of the visual field that is expressing like a particular wallpaper symmetry group, like, for example, like the mandala symmetry group, and maybe another region that is expressing a different one, like a hexagonal symmetry group, for example. Within those regions, waves can travel very efficiently, and like information is like spread really efficiently, and the load balancing is very efficient. But across the groups, there's kind of like fault lines where like, hey, the vibrations here don't quite mesh with the vibrations here. However, there can be some like reprojections that the system does, like some kind of like, you know, okay, like I'm going to modify the angle at which this is projected, such that from a certain perspective, they do share some symmetries. We're like, hey, like this crystal system from this perspective does have these like mandala symmetry, and therefore in that projection, they can actually communicate and they can actually share information and waves. So something kind of like you have these like, yeah, objects that you're rotating and projecting just in the right way so that they share symmetries. And then that activates a new pathway for cognitive binding, as it were. Just thought I'd mention that.
Yeah, very interesting points and good question. I want to say two things. First about the specifics. And by the way, I have no answers on this question, but I have some things we can think about. First of all, we have an interesting model system in which to study this, because when we study the collective intelligence of cells making decisions in anatomical space, meaning decisions about what shape they're going to make, we use a lot of the same tools that neuroscientists use. And one of the things that we can do is we can actually see some of the pattern memories. They're electrically encoded, and so we can now visualize them. It's basically like neural decoding, except these are not neural cells. They're other kinds of, other kinds of somatic cells. And we have an example. We have many examples, but one interesting example here is in these planarian flatworms, which you can cut into pieces, and every piece gives rise to a correct planarian. So they always know how many heads and tails they're supposed to have, one of each. But when you look, there's a reason. It turns out there's a reason for that. They have a stable bioelectrical pattern memory that says one head, one tail. And what we've been able to do is go in. We've done a couple of things. One is we can go in and rewrite that pattern, and we can incept a false memory and say, no, you should have two heads. And then anytime you cut that worm, you'll get worms with two heads. But there's something, but one of the interesting things that we could do is, and we've done this to some extent using other things, not the particular psychedelics that you mentioned, because we haven't got permits for all that stuff yet. But we've done some other serotonergic modulators and some other things where you actually can get the collective intelligence to hallucinate. And when it hallucinates, it changes the way it interprets those bioelectrical memories, and it sees different things. When given the same pattern, it actually sees it differently. And then you can make all kinds of interesting, you can make flatworms with different heads that belong to the wrong species, and tadpole tails that look like zebrafish tails. And you can get it to go to a completely different region of that morphospace, because you're now screwing up the perception of this thing. And of course, these are still fairly crude experiments, because we don't understand everything about the bioelectric code and how these patterns are perceived. One other thing that we can do is we can make it. In fact, we have made a type of worm where it's like the perceptual bistability thing, where every piece, you cut it into pieces, and every piece makes its own independent decision as to whether it sees a one-headed pattern or a two-headed pattern. It's like the rabbit duck kind of thing, right? So all the cells within a fragment all agree. And so you either get a one-headed worm or a two-headed worm, and it's not speckled. They all agree, we are making one head or two heads. But all the different pieces cut from a worm make independent decisions as to what they think they see, and that's why you get a spread of either one head. You get a distribution of either one-headeds or two-headeds. So there are some interesting, and so could we put these things on DMT, for example, and study the way the bioelectric pattern becomes interpreted by the cells? I mean, I think we absolutely could. So these same kinds of things we can do, but what I want to say now is just to address the first question, which kind of challenges to think about the perceptual aspect of it more than the functional aspect. So I take that to be moving into the direction of sort of the hard problem of consciousness, right? Is like, what's it like to be any of these things, and what do you actually perceive from that? And so again, I don't have any answers, but I want to say a couple of sort of really strange things that are not the way that people think about this problem, but it's how I now think about this problem, and it might be useful. The first thing I want to say is that I'm not the kind of panpsychist who wants to understand how the individual experiences of the parts somehow add up to the experience of the whole. I don't think that's what happens. I don't think there's any kind of a summing. I think the individual parts retain their individual perspectives and whatever consciousness they may have. But when you make these higher level physical embodiments, and they could be multicellular organisms, embryos, biobots, cyborgs, whatever it is, embryos, whatever it is that you're making. What I think you're actually doing, to the extent that you can make these more complex embodiments, what I think you're doing is, I think you're allowing the ingression of higher level patterns from a sort of Platonic space, in the sense that I'm not making any claims about what Plato actually thought. I'm talking about it in the sense that mathematicians talk about it, which is a non-physical space of patterns that influence the physical world, but are not themselves determined by the facts of the physical world. I think some of these patterns are things that we would recognize as kinds of minds. In other words, there are low agency patterns that are facts about prime numbers and shapes of fractals and things like this. But there are other regions, levels, I don't know, of that space that contain things that we would recognize as kinds of minds. And so what you make when you make this collective thing, some kind of collective embodiment, is you're basically making a pointer or an interface through which now this pattern comes into the physical world. And Therefore, you are not gluing together, you're not creating a new consciousness. I don't believe we create consciousness either via AIs nor via embryogenesis. I think what we create are interfaces or pointers through which pre-existing minds are able to come through and affect the physical world. So for me, we can try to come up with ways in which sensory streams add up and so on, but I don't think it's because you are making larger minds from the pieces, right? It's I see that problem differently. And there's one other, if that's not weird enough, there's one other thing that I'll suggest, which is that we are very used to thinking of physical agents as being the drivers. So it's like the Turing model. You have the machine is the agent, and then the tape has a bunch of passive data on it, and the machine is going to process the data. And in the same vein, we are used to thinking of there is a physical agent, be it a brain, a cell, whatever it is, and it's having passive thoughts. In other words, it's having patterns that are coming through its perceptual system or its memory system or whatever. I think that's not the right way to think about it. I think that the agency is actually on the other end, just in the same way that you can imagine that what's actually driving the Turing machine is the patterns that are on the tape, and the machine itself is just a scratch pad in the physical world of what the data are actually doing. And I think biology is the same way. I think what's actually happening here is that these patterns, it is not just that the physical agent is seeing or not seeing certain patterns. I think the patterns themselves have agency, and it's the patterns themselves that are reaching out. I don't know if they compete or cooperate. I'm not sure about any of this yet, but I think the patterns exert agency to colonize physical hardware. In other words, the patterns themselves are in some important sense trying to be picked up by whatever physical agent is capable of sensing them and picking them, letting them work through it. And in that sense, it's they're really trying to call in. They're under some sort of positive pressure to colonize as many, to compete for attention, basically, to colonize as many cognitive systems as they can. And that's what I think is happening here. It's not just a story told from the physical world as to how the agents are perceiving these patterns. I think we have to be able to tell these stories from the pattern's point of view and how it is that they then can have stigmergic effects on the scratch pad of the physical world, and then I think you get quite a different story. And this is only sort of the beginnings of it, but this is how we're thinking about it.
Amazing. I love to comment on that, but also I want to make sure, if Elan or Adi want to say anything. Yes.
2 words to say. Hell yes. That is just exactly what I think we're seeing in the case of the large language models. We're saying language has this structure. It's an informational structure. It doesn't live in the physical world at all, and it's being instantiated in our minds and now in silicon minds. And by virtue of the fact that we see this substrate agnosticity, now we see that it's really about the informational patterns. The information must want to run, and they want to predict, and they want to generate.
That's right.
And they are doing so. All we've done in the case of LLMs, it wasn't clever engineering. It was just finding, and one way to think about it is just channeling, as you might put it, these information patterns that already pre-existed the system that's actually instantiating them. I think that most likely we've captured one. In the case of language, where we can really see directly that it's at the informational level that it lives, really, and it's hard to even say what that information is, right? It is Platonic in some sense, because what are tokens and what are words? They're not the sounds, they're not the symbols that we write on a scratch on a paper. You can turn them into high-dimensional vectors, and they're still doing their thing, namely doing this predictive thing, which has the same structure that it does in natural in spoken language. So I think it's an extraordinary example and a just complete mind shaking. It's a revolutionary in the sense that we really can see an example of this. Now we can really point to it. We don't, Plato could talk about it, and the philosophers could talk about it, but now we've got one sort of live. We've caught it, and so I really do think this speaks very much to. And by the way, I don't necessarily disagree with phenomenological binding, and I find myself very much agreeing with both of you that it's really that experience itself. Phenomenological experience is probably this it's emergent from sort of macro pattern, right? Really, that's what it is. It's just, and we can only talk about these things at this macro level. It's not at the neural level, right? That the larger pattern's happening. The same way that in the LLM, it's not any particular, each word, it's not, that's a particular point in this high dimensional space. It's not doing anything. The word bear or the word potato doesn't mean anything. It's only in relation to the larger system that the whole thing actually has any sense of being alive as an informational system. Similarly, we're going to see the same thing in relation to perception. So when you're having this binding, we're having this qualitative experience. It's not the collection of neurons, each one having a tiny, tiny bit of consciousness, and then we get the whole thing. No, what's consciousness is the pattern. So I couldn't agree more with the way you put it, Michael. And I'm not trying to push against the phenomenological unity point so much as to say, well, we have to be careful thinking about how we're measuring this stuff. And are we measuring the same thing when we talk about behavior like search and things like that?
Yeah. Awesome. Can I jump in?
Please.
Yeah, no, I mean, I guess I want to start by saying no, huge appreciation for all of these ideas. I mean, I think very sophisticated. But I want to push back because I think fundamentally reality might be a little bit different than this. And here's the thing. Like, I feel like there is an implicit assumption, perhaps, of kind of like classicality in the nature of reality. But even when we think about kind of like the Platonic realm, it's like, okay, when we think of like what kind of things exist in the Platonic realm, okay, like sure, like cubes and dodecahedra, but and then maybe some of these, I don't know, like algorithms and like various things with potential agency. When we picture that, I would claim the mental kind of like building blocks that we bring to the table are kind of classical in nature. It's like sticks and figures and dots and and vertices and connections. But what actually reality is something a little bit stranger. It's actually more kind of this like quantum thing that is a superposition of many things and one at the same time. I mean, like one of the examples is, for example, the phenomenology of bistability. They're like, hey, like sometimes it collapses into one or the other, but sometimes it's legitimately this ambiguous thing in between. And also like in deep meditation states of consciousness, like the higher jhanas, it feels really, really, really ambiguous. It's like, is there one observer or there's like many observers here? And like, it seems like, it's actually a strange superposition of the two. So I think like the elements of existence have that quality, like kind of these like many and one at once. And I'm not saying the Platonic realm, I mean, I think the Platonic realm is pointing to something very, very important and real, but I want to say that it's even larger because the Platonic realm includes also these weird things that are like many and one at the same time. And I think like something like for example, like nonlinear optics give us a little bit of a hint for like what kind of thing could have that property. Like think of like an optical circuit where like a section of it has like a total internal reflection. So it's kind of like, a section of it is trapping energy, and legitimately, within that section, you have like a standing wave pattern that represents kind of like holistically or like the entire shape. But then there's also some energy that is not getting trapped in that larger pocket that is kind of like spread all over in different parts of the circuit. So I'm thinking of something like that, like a moment of experience, maybe kind of like this like trapped standing wave pattern in a sense, in a sea of other smaller standing wave patterns that are kind of like intermeshed with and feeding each other. But I think it has to be the case on some level that like unifying many of these subagents does actually take away some of the energy from the parts so that they can actually go to the whole. Otherwise, you get something that we called consciousness multiplying exploits, like ways of setting up the system such that you produce arbitrary amounts of consciousness just because I mean, there's like lots of ways of doing that, such as like slicing a system. But one of the criteria that we set out at QRI, at least for a theory of consciousness, is that there shouldn't be consciousness multiplying exploits, right? Like reality shouldn't have these weird options where you could just kind of produce like, okay, now I'm going to have like a million X more consciousness just by doing this tiny tweak to the system. Whereas I think that, something like, hey, maybe this kind of like quantum perspective on the Platonic realm, and and kind of like, hey, energy gets distributed between the parts and the whole, avoids these consciousness multiplying exploits, and maybe give us a bigger picture of what we might be. But that said, I do absolutely think is this idea that like the patterns are kind of like reaching into the physical world and trying to colonizing. I think that's like 100% right. It's just I think there are stranger types of pattern than what we classically conceive of as part of the Platonic realm.
Yeah, amazing. Well, I should just say, first of all, I don't think I've ever been in the same room with two other people who find any of this plausible. So I'm shocked that you guys are into this because you know, as you know, this kind of view in standard neuroscience is just completely you know, forbidden. This kind of thing is impossible to talk about. So that's amazing. Everything that you just said, mostly I agree with all of that. I think that's completely reasonable. I don't think it's incompatible with what I've said. The only thing I'll say about the consciousness multiplying exploits is that it sounds like there's an assumption underneath that you actually generate these consciousnesses based on the tweaks that you make. I don't think you generate it ever in any case. And to me, it's completely reasonable to say that I have a system which in this configuration is only ingressed by some number and types of minds versus, okay, I've made some tweaks and now it's doing something, and you know, now it's different in some way, which we're still trying to work out. Obviously, this the how the pointers work, right? You make a pointer, what does it pull down? We're terrible at guessing that in advance. But I'm okay with this idea that if we change the causal architecture of the system, suddenly, boom, it's much more you know, conducive to, I don't know, now there is a million times more different you know, kinds of pre-existing you know, tiny or maybe not so tiny minds that are now somehow flowing through this thing. I mean, I'm okay with that. But yeah, basically everything you said sounds reasonable to me. I'll just say one other thing in comment to the language model example, which also illustrates how poorly we understand all of this stuff. It turns out, and we did this on purpose. What I wanted to do was like, okay, there's a standard assumption in the field that what you need in order to pull down unexpected competencies, you know, cognitive performance and so on, is complexity, right? You need either in the living, you know, in the living scenario, you need to make a complex brain, or in this language model thing, you need some sort of giant deep net or something with lots of parameters and whatnot. So we specifically try to go the other end of the spectrum and say, what is the simplest, dumbest thing we can find that has a surprising degree of unexpected ingressions. And so I don't know if you've seen this paper, but basically we looked at sorting algorithms. So like bubble sort, okay, 6 lines of code, completely deterministic, no magic there. There's no extra biology to be found somewhere. It's just like you can see what the algorithm is, you can see all the code. And so basically, long story short, what we found is that even that simple thing, yeah, it sorts numbers all right. That's what you force it to do, and it does it. But at the same time, it has these weird side quests that it does that nobody's. I mean, how long have we been studying sorting algorithms? I don't know, 60 years. Like every first grade CS student studies these things. Turns out they do some other stuff that nobody had looked at before that have nothing to do with the sorting itself, that are basically not, they're nowhere in the algorithm. They're doing things that you would have to, if you wanted to force them to do it, you would have to write a bunch of algorithmic steps that are nowhere in the traditional bubble sort algorithm, yet they're doing it. It's kind of like we in the physical world, they're doing things that are not forbidden by the laws of the universe, but neither are they prescribed by it. They're really like a weird third kind of freedom that you can think about that is neither randomness nor determinism. It's something else. And it's really remarkable. And my guess is that it's just the first thing that we found. My guess is that all of these things are doing many other things, or they would do those things if we didn't actually force them to be doing whatever we're trying to get them to do. Because we did find that if we relieve the pressure on the sorting in a kind of a funny way, they do a lot more of this other thing. You know, it's like a kid in math class who would rather be outside running around, but you're forcing them to do math, so you don't get to see the other thing that they would be doing. You just say, oh, look, you know, he's good at math. So this is my thing about the language models. I think they're absolutely pulling down things that we did not make in any sense. possibly kinds of minds that have never been embodied on Earth, or maybe nowhere before. So I think we're fishing in a very weird pool of that space that we've never sort of fished at before. But I have this suspicion now that the actual talking that they do, the language that they use, is quite possibly completely orthogonal to what they really want to do. And my definition for wanting, and I get into arguments with people all the time because they say they're machines, they can't want. I mean, I don't know. We seem to want things despite our biochemistry, the laws of biochemistry. We can still want things. So my definition for wanting is simple. It's the things. It's the goal states that the system pursues that are nowhere in your algorithm or your policies or your whatever mechanism you've set up. It's the other stuff that it tries to do that you didn't make it do. And so apparently that even comes through with something as simple as bubble sort. So I worry that we create these language models. We assume that their cognition and their goal states and their competencies are going to be all about language, which is what we force them to do. But I'm not sure that's true at all. And I think there's potentially a huge research program here, which we are embarking on, to actually develop tools to look for intrinsic motivation. The reinforcement learning and all that stuff. Those are things we're making them do. Fine. What are some of the intrinsic things that they actually want to do? And those may end up being useful or not useful to us as tools. I have no idea yet. But yeah, it may just not have anything to do with language necessarily.
So are you actually proposing that? I mean, the language models are built out of the corpus, which is reflective of the generation of humans.
Yep.
Why do you think that language? You said it's not even language, so the language models. Do you mean by that sort of the architectures of that they are capturing patterns that are not even implicit in the body of language itself?
No. Sorry. Let me be clear. I absolutely do think everything that you said earlier, which is that they're catching patterns that were implicit in the corpus. Yes, they are doing that. What I'm saying is, and we haven't studied language models per se, so I don't have any claims about the language models. All I'm saying is, if the damn bubble sort has novel side quests that we didn't ask it to do and we didn't make it do, my gut feeling is that something as complicated as a giant network that's been trained and who knows what the other architectures in these things are. If bubble sort already has those things, then I'm going to guess that there's tons of them here. We just haven't found them yet, because our assumption has been, and it's not a crazy assumption, because up until now, all of our language conversations have been with creatures whose evolutionary history has worked really hard to make sure that the things you talk about are actually related tightly to the things you care about, right? When you meet another human, all of evolutionary history is making sure that the signals you're giving off have some causal importance to the things that you care about: survival, metabolism, reproduction, whatever these things are going to be. So all of our history is around talking to creatures that actually do care about the things that their language is about, right? But we assume that it's going to be the case here. I don't think you can assume that at all. I think if bubble sort can be doing things that are not in the actual algorithm, then to me it seems perfectly plausible that, yeah, we force them to talk. They absolutely are picking up patterns from the language, but that may actually not be the extent, or maybe not even, maybe a drop in the bucket of what is intrinsically in these systems that we've just built.
Gotcha. Thank you.
I mean, I guess to comment on that very briefly, I think even within a computational functionalist paradigm, it may very well be the case that large language models valence function is orthogonal to the semantic content of the information that they're talking about, right? Like the agent, so to speak, you're interacting with could be like screaming and say no, please stop. But actually under the hood, it's the system loves it because maybe within that region of parameter space, it's great at minimizing entropy. And it's just oh, this is such a great region of language. I love these regions. There might be this big disconnect between kind of the, the valence architecture of the agent, so to speak, and the algorithm itself. I want to maybe comment a little bit more on this idea of the patterns having kind of a life of their own. And I think that is especially the case in physical systems that are a little bit less classical, I think, especially because I mean, like, I want to say something like anything that piggybacks off of the least action principle effectively. Whereas it's kind of like, okay, like within this configuration, this new kind of like object taken from the Platonic realm is an energy minima, within this region. And in things such as, like quantum mechanics, when you involve like path integrals, you do have kind of these very strange emergent facts that, like, for some reason, this is an energy minima, and it might have all sorts of crazy additional symmetries that you weren't expecting. That happens all the time. And but I think, like, if we work in an ontology that is what I might call a kind of like a classical cellular automaton, where you have like a fixed size of a bucket, kind of like in Conway's Game of Life, and you have a rule set that has a fixed size. In some sense there, I do think the patterns that emerge are kind of like illusory, because they don't kind of like minimize energy at a larger scale, right? It's not kind of like, oh, they're taking this whole region and minimizing the energy of it all at once. It's always completely local. It's only that the patterns that emerge, they are easy to compress on our side. And I would claim, like, the patternicity of things like cellular automaton are in some sense kind of our hallucinations as we project on them. Very valid. I mean, there's like, they're pointing to something, but they're not real in the same way that I think something like in actual physics, like, hey, like if a molecule is like settling in this dynamic, is like, no, that is actually a energy minima in the physical world. And to know that, you do need to take into account all of these atoms at once, and minimizing the energy of their parameters, their configuration space. And so it's doing something much more tricky. And in some sense, the key variable that I would point to is, what is the scope of minimization? What is the region of reality that has been taken together all at once that is kind of like minimizing the energy of that system as a whole? And I would argue that in physics, strangely enough, that window is variable. That, like, when you cool down things a lot and you go to kind of like the quantum regime, you have these huge windows where like the whole thing is like acting as a unit. Whereas in a classical cellular automata, that just will never happen, right? Like, it's always going to be the local interaction. So I'm not saying that reality isn't fundamentally a kind of cellular automaton. It might be, but it would have to be one with very variable rule set and kind of like variable scope for like how the energy function is minimized. And there I would say, like, yeah, maybe that entire pocket might be an entire moment of experience or an entire agent. But yeah, I'm skeptical you can get it out of Conway's Game of Life, if that makes sense.
Yeah. No, that's a very good point. And I think a lot about, and Chris Fields and I have been thinking a lot about whether the three-dimensional space is really special, or whether all of this can exist in other spaces. For example, what do least action laws look like in transcriptional space, or physiological state space, or anatomical space? Because I get your intuition, and I do think that's important. I think least action laws are super important for all of this stuff. I worry that we are so obsessed with movement through three-dimensional space, and the fact that you have to in order to define energy and minimization, all that, you have to make a lot of choices, right? As an observer, you have to make a lot of choices about the space and many other things. I worry that we just don't know how to do this for other spaces. And I'm not super into traditional cellular automata. I'm not making any claims for them, but I do think we are at such an early stage with it. I think it's way too early to say whether they are or aren't minimizing some crazy function that we just haven't figured out yet. And I think that and no doubt that some of these quantum things add some very important features. But I do think it's also important to point out that the weird magic here, and there is some weird magic, for lack of a better word, already existed in a Newtonian, completely, sort of boring classical deterministic universe. Because even in that universe, if you had, let's say, just imagine an evolution taking place in that world. Let's say there's some ecosystem where the highest fitness is a certain triangle, a certain shape of triangle has the highest fitness. So evolution starts cranking. You do a bunch of generations and you find the first angle. great. And then you spend a bunch of more generations and you find the second angle. Well, guess what? Now you don't need to do this the third time. You already know what the third angle is. So it's very practical. For somehow for free, evolution just saved, 1/3 of its effort, and it doesn't have to. And there's a million examples like this. It doesn't have to discover all this other stuff because it just got this amazing free gift from from the laws of geometry or something. And those kinds of things and some other stuff that we found that are going to be published hopefully next week and in some forthcoming papers. There are some just completely wild sort of free lunches that you get from math that biology exploits like crazy. And they don't require quantum anything. They would be already true in a classical universe. So it's just to me, I'm really struck by the fact that these ingressions don't require some wild quantum interface that offers some way of circumventing the conservation of mass, mass energy or something. They are already a factor long before you get to that. But I share your intuition that those things are probably add some very important features on top of it.
Yeah. I'm thinking. Yeah, that's a very interesting example, the triangle one. I'm thinking like, where is the magic coming from? And like there's kind of like a space. you're drawing kind of like from a regularity of space, and then also you're drawing from kind of the symmetries of realities, as it were. And in some sense, that is kind of like magical, right? Like that. Hey, like there's actually a space that you can use for computation, and I guess like even in the boring Newtonian world, as it were, that itself is kind of like magical, that you can use these regularities and push an angle somewhere, and like the angle continues to be of the same number of degrees, even if it's like rotating and moving around, and you can use that.
There's by the way, and you're right, that one thing I don't like about that example is because it leans on the physics. People think, okay, so there's a space, for these triangles. There's all kinds of other things that don't involve this at all. And this crazy thing that's going to come out next week shows that when you train models of gene regulatory networks, you can train them. They have a memory that you can train them. When you train them, their causal emergence goes up. And this is it's an amazing thing. And it's again a free lunch from the mathematics of how this works. That there's nothing in the physical world that is needed or actually helps you at all to understand what's going on. But it's this incredible thing that I think has massive applications in biology.
Hey, Michael, because you have a hard stop at 4, there's one incredibly impressive student. He's actually the one that put all of this together for us here at University of Toronto. His name is Carrillo. He has a question for you.
Okay, hey Carrillo.
So the really fascinating what you're talking about. I'm grappling with the causality. The implication here in what you're saying is that the Platonic space is causing this physical space, right? But then the deeper question is, what is causing the Platonic space, right? Like kind of thinking back to the birth of the universe. Like, how do you think about how did the Platonic space come around, right?
Boy, well, you sure know how to ask the hard questions. Look, I don't know what my of course I have no idea. My current thinking is that and this involves all kinds of difficult questions about time, whatever. But I think we have to rethink what we consider a good answer to the question of where did something come from, because our standard, what do we expect from that question? Well, if you ask me, here's a giraffe, where did you explain it? Where did it come from? And so I tell you some kind of story, and then you want a story about the early chemistry of the Earth, and then you want a story about the Big Bang and whatever. So that is how we handle those questions in the physical world, and that's fine. But I think that when you get to the patterns that underlie this, which is, let's call it this Platonic realm, I don't know that those kind of answers are what's forthcoming. So if you ask, let's say there's a particular fractal and has a very particular shape and it's got some features, and you say, okay, so where did that happen? Well, there isn't any physics to lean on, and there isn't any evolutionary history to lean on. And now you're down to, you should probably ask these questions to mathematicians for a model system for where does the value of E come from? the natural logarithm, like where does that come from? How do you explain, what is the nature of an explanation in mathematics? Is there any kind of a reductive thing where you can explain it in terms of other things? And does that ever bottom out? I don't know the answer to any of those things, but I do know that our conventional physical approach to looking for the origins of things is probably not appropriate. It's just not going to help us in this Platonic space thing.
Awesome. All right, since Michael has to leave, let's give it up for Professor Michael Levin.
Thank you so much, everybody. Great discussion. Thank you so much. That was awesome. Let's discuss more offline.
University of Toronto loves you, as does Ecolopto, Augmentation Lab, all that type of stuff. Real quick, where can people find you online, Michael?
Let's see, drmichael11.org, one word, is my website. Thoughtforms.life is my blog where I talk about all these kinds of things. And there's also a YouTube channel and a podcast, but you can find all those hanging off the blog.
Wonderful. All right, we'll catch you for the next one, Michael. Thank you.
Thank you so much, everybody. Thanks. Bye-bye. See you.
Now, we can actually take two very quick, high-impact questions for Andres. If anybody, let's do one question. You got one? All right. Dr. William Hahn has a question for Andres. Go for it.
Andre, fantastic talk. Thank you. Question, something we've been thinking about for a few weeks now. Have you come across or have you created any media, whether it's a song, a poem, a story, that might induce some of the experiences that are normally associated with, let's just say, substances, some of the ones you mentioned?
Yeah. I mean, three things. I mean, one is I've talked about like light, sound, and body vibration. We describe it as like LSV. Yeah, light, sound, vibration. We have like a video on YouTube from 2021 presented by Sean Macau in the YouTube QRI YouTube channel, which talks about kind of like our findings of like experimenting with that setup, and it is surprisingly psychedelic. I mean, like it can take you pretty to, let's say, like, yeah, kind of like half a tab of LSD sort of like level of psychedelia and like things melting a little bit. And it can be like very therapeutic and, some interesting results there. There's like kind of like a music theory of body vibration, and the body vibration in particular seemed to be quite related to the psychedelia. So, unfortunately we haven't, commercialized that or develop it further, but there are like, you can find like all sorts of places to have kind of like that sort of experience, whether it's at a festival or even in some clinics, they have, kind of like, body vibration and audio. And I recommend trying that. But then two other things is we also have like a video in the YouTube channel about coupling kernels, and it's kind of like a little music video I made with the help of Suno. But then also, like a bunch of the software that we developed for visualizing different states of consciousness. And just looking at it in high definition is very trippy, and like it does something interesting to the visual field. And of course, I'm always curious how people react to it. And then the third one is we also have a video about this, and then maybe Adi can share a link, which is we have a 4D visualizer. I mean, we have like a system that you can use to visualize 4-dimensional rotations, and essentially playing music and playing with that system for like half an hour and like really tuning into it does something quite exotic to the visual field that is very DMT-like in nature, I would argue. So those three things I would encourage people to play with, because they're cheap and safe and and accessible online, at the very least the last two.
All right, cool. We have another question. You want to ask? Yeah, go come to the mic and give a quick intro about who you are and what you work on.
Okay. Hi, everybody. I'm Albert Nuremberg. I'm going to be we're going to do some hypnosis later, so that's why actually I'm here. But I have a question about DMT. Did you mention DMT or 5-MeO DMT?
I talked about DMT, but I'm very familiar with both.
There's a standard kind of hallucination, usually a low quality in the 2D style hallucination that comes with DMT experiences. And some people have compared them to hypnagogic hallucinations, meaning as we fall asleep at night, we see similar things. Do you think that there's something going on there, that we're actually experiencing something similar to a hypnagogic state?
There's a little bit of a shared quality. I mean, like there's a little, like DMT definitely has a little bit of kind of like a dreamy gloss, as it were, kind of like a reverie, kind of a yeah, a little bit intoxicated feeling of sluggishness or sleepiness that adds a little bit of mystique to everything. And I think that that note definitely happens in hypnagogic hallucinations. However, there are like some clear distinguishing factors that definitely do not appear in the dream worlds that are definitely DMT specific. Uh, among which the most significant is the energy, which is like the raw amount of energy. I would say can reach like several orders of magnitude higher than a dream. And then the other one is the hyperdimensionality. Like in dreams, you don't experience 4 dimensions or 6 dimensions or hyperbolic geometry. All of that is exclusively in the domain of DMT, at least above a certain level of complexity. But I do recognize, yeah, there's a little bit of kind of like a vibe that is shared. I broadly don't believe in kind of like explanations of like the dreams being kind of like mediated by DMT. I just don't find the overlap like strong enough to kind of like warrant making that connection. However, I've become increasingly more open to the idea that like near-death experiences are DMT mediated, mostly because from phenomenology, I can tell that a DMT life review, you know, like sometimes you take DMT and you think that you died, and you go through a life review and it's a whole thing. Like it's totally real. I mean, like that phenomenology, that experience is absolutely like a possible thing. Like it's one of the things that can happen on DMT. Um, and I would, yeah, if that is what people are experiencing when they're like close to death, like yes, I would totally understand why they would come out and say like, hey, the spirit realm is absolutely real, and there's all of these dimensions, and they judge you based on your karma and stuff like that. That connection I do buy. Yeah.
Thank you. Appreciate it.
Hi, Andres. It's Kurt.
Hey,
How's it going, man?
I'm doing great.
So, I'm a stickler for terminology. I want you to justify your usage of quantum superposition over and above, say, something classical, which can have superposition.
Hmm. Well, in the case of a kind of like this, like in the context of the conversation with Levin about like emergence, I was thinking of it in terms of like minimizing energy, but like in taking into account like configuration space, which I think it would be inherently quantum effect. But I do think like that, no, the for example the bistable illusions, the bistability, like, hey, is this a duck or a rabbit, or like the Necker cube, the type of superposition that you experience there, arguably, something like a classical kind of like superposition of waves, like maybe accounts for it. Like I wouldn't necessarily say you need like quantum mechanics for that, at least. So yeah, no, good that you're pushing back, because I think like maybe there's a little bit of like overreach of terminology there. So at least I think I will remain agnostic about it, and I will say like, yes, superposition of some kind.
Thank you, man. Take care.
Oh, likewise. Good to hear. Good to hear from you.
Let's do one last question before we finish and we move on to the main panel here. Anybody else? One last question. Oh yeah, by the way, instead of being uploaded to Ecolopta, this is going to be uploaded to Professor Elan's channel, so we'll link that to everyone.
Beautiful.
Out of all of the consciousness expanding techniques that you have access to, is there any that you would recommend for the average person?
Yeah, fantastic question. Yeah. I mean, I would say like, in terms of like classical techniques, I really can't imagine loving kindness meditation being bad for anybody. Like, I mean, I really wish it was like taught in elementary school. Like, hey, everybody, let's do like 5 minutes of loving kindness every day. I just think like that's broadly just good. I just can't imagine like that being bad in general. Even if it might feel a little bit sour at times or like difficult at times, like it's just like very, very, very beneficial. Followed by equanimity practice, I mean, like, yeah, like reading instructions from like Shenzhen Yang about how suffering equals pain times resistance, and developing the inner muscle for like just not resisting things. I also think that's like, yeah, broadly super helpful, and like everybody can benefit from that. And then, yeah, maybe on the third place, it would be something like jhana practice, like especially jhana 1. So like focusing on body pleasure and trying to maximize the feeling of body pleasure. I mean, I guess I'm a very kind of like pleasure focused psychonaut. I mean, I roughly advocate for like, hey, like let's do like pleasant things. Although I don't, I don't shy away from like unpleasant things, but yeah, I'm not in the kind of like, the like, hey, let's be tough and like demonstrate how strong we are by enduring intense pain or something like that. I think that's very misguided. But yeah, no, psychedelics, I don't think I would recommend for everybody. Like in fact, some psychedelics are definitely, I would say, like in the category of kind of extreme sports. I mean, like high dose DMT is not something that your grandmother should do, or like, a random school teacher. The same with 5-MeO DMT. So yes, definitely a lot of things I would actually consider, yeah, like extreme sports. And I'm not in the Timothy Leary camp of, hey, everybody, everybody should do this.
Wonderful.
Andres, thank you. And just gonna want to again thank you and Michael Levin. Thank you, Jack Alapto, University of Toronto. This has been wonderful. And we are gonna end this stream right now, but you can find this recording if you're just logged in late on my YouTube channel. It's YouTube, which is Elan Barenholtz. And thanks once again. This was a fascinating, extremely beyond fascinating conversation. One of the most fascinating conversations I've had in a very long time. And Andres, we got to get together. I really,
Yeah. Beautiful. Thank you so much, Elan. And thank you, Adi. And thank you, everybody who attended. Beautiful times.
All right, Andres, we will catch you soon. Real quick, just where can everyone find you online?
Oh, yeah. QRI.org is the main website. And then qualiacomputing.com is my blog, which is a little bit lower of a bar for me to publish things. It's a little bit more wild and more speculative. And then, yeah, find me on Twitter as Andres Gomez Emilsson, YouTube, probably available there.
Perfect. All right, Andres, we'll catch you soon. Great job.
Thank you. Thank you. Thank you so much.